Hi everyone, today let us learn about cis-trans isomerization, which is also called as photoisomerization. We all know isomers are two or more compounds with same formula but different arrangement of atoms in a molecule, and also their properties also may differ. Now usually what happens when we take a double bond like this, which is still being, usually the interconversion of cis and trans isomer becomes difficult because of heavy groups like phenyl group, which you can see here in the structure of stilbene. But still, isomerization of either of the two, that's from trans to cis or either from cis to trans, is possible because there will be a change in the transition state. So we will understand about what happens in transition state. But usually we should know that when, in this example, trans stilbene takes up energy of suitable wavelength and then it is converted to cis stilbene only because of a particular transition state which is suitable for the conversion of trans to cis. So we will just have a look at the stereochemistry here. So here you can see the trans isomer when it takes in energy of required wavelength is next step would be a formation of a transition state. Now in transition state you can see very carefully how the geometry is a twisted geometry, that is the p orbitals are perpendicular to one another. So here you can uh, observe how the one of the p orbitals remain perpendicular to the other p orbital. So in this way, in transition state, there is the isomerization is actually nil, or it's cancelled out. So mainly they, in the transition state, there is neither trans or neither cis isomer which is seen in the transition state. Okay, so this way, and because of this perpendicular geometry, what happens is there is no problem of steric hindrance either. Okay, so that is the reason why most of the isomerization can happen even though there is an olefin as a substrate. So now the next would be how the transition state undergoes the cis isomer. So here you can observe how the product, that is cis isomer, has been formed because both the R groups are on the same side. So this is what is called as the twisted geometry, and this helps in the photoisomerization, that is from converting trans isomer to cis isomer. Thank you very much.